let's do problem number 17 on the vector conversion worksheet. And here it is right here. And it's vector M. I just gave it the letter M. I'm just using M as that. So given vector M, and I'll put a vector hat on top of it. Say, hey, that's a vector quantity is equal, and I'll write it in coordinate form, 22.4 millimeters, negative 4.32. Oh, I think there's a typo in there. It should be millimeters. If you make it meters, it's a really weird vector. So, yeah, I didn't notice that before. Right here, everybody on your worksheet, let's make it millimeters. So, good job in picking number 17. You get 3 more questions today. All right, now, given, and then what do you want to find? Well, we want to find the magnitude of M, and we want to find the angle that M makes with the positive x-axis. So let's solve it. Now the first thing I do is draw a sketch of the vector. Okay, so here's my xy axis, and I'm going to look at this in the negative. It goes in the negative x 22. So we'll make this 10, 22, something like this. And in the y, you go down 4.32. So it's going to look something like this. There's vector M. You see how I did that? I went over to the left 22 and then down 4 or something close. Now it's not perfect, is it? No. Does it have to be perfect? No. It just has to be kind of close so you can visualize and see what where the vector's at. I can tell right away that this angle is greater than 180 degrees. If I get something that's like 12 degrees, I'll know I did it wrong. Okay, so to find M, to find the magnitude of the vector, if you're given rectangular coordinates, use the Pythagorean theorem to get the magnitude, because here's the x component, here's the y component. The x component and the y component always make a right triangle with the magnitude of the vector. So, the x component squared, do I have to put the negative on there? No, I just drop the negative. Why? Because I'm squaring it. Any number squared is positive. So, I mean, you can, okay, I'll put it in there just to make somebody happy. Doesn't matter, it's going to get squared. So, let's see if I can use this calculator. It's kind of a new calculator for me. So, we're going to take the square root, second function, and then we're going to go 22.4 squared plus 4.32 squared, close parentheses, equals 22.8. Is that what you got? Anybody else doing this? Don't trust me. Question authority, people. I'm old. I might have a hidden agenda and be leading you astray. So there's the magnitude. Now let's figure out what the vector is. I mean, the angle is. The angle is equal to the inverse tangent of the x component, of the y component, divided by the x component. So let's plug that in now, the numbers. The y component is given to be negative 4.32 millimeters divided by negative 22.4 millimeters. So if I do that, what do I get? So I go second function tangent. Oh, oops. System salt. What? Oh. Oh, I bet I have to hit it twice. There we go. Oh, that's clever. Tangent negative 4.32 divided by, okay, here I am doing that, negative 22.4, enter. 10.9 degrees. That should be my angle. Now I'm looking at my drawing. Is that correct? Is 10.9 degrees correct? No. 10.9 degrees is up here. That's 10.9 degrees. So what do I have to do to my answer? What? What do I have to do to the answer? I have to add 180.
Yeah, that's right.
Way to go, Grant. So it's 10.9 plus 180 degrees, which is 190.9, or you could put 191 degrees. Now, does that make sense? Does that agree with my picture? Yeah, it does. So I can say that vector M is equal to 22.8 millimeters at an angle of 191, I'll go ahead and round it off, degrees. It agrees with my picture, and I showed my work, and everything's great. If the x component is negative, you will have to add 180 degrees to the angle that you get by using inverse tangent on your calculators. Please don't forget that. It's an easy thing to forget, but if you draw a quick little sketch of the vector, you should be able to catch little mistakes like that. Another big mistake students make is they will forget to take the square root. Well, if you forget to take the square root of your answer, you're going to get a huge value for the magnitude, way bigger than these. Should only be a little bit bigger than your biggest one. Okay? A little bit bigger than your biggest one. So if it's a lot bigger, you probably forgot to take the square root. Easy mistake to make. So in this problem, we converted from, we were given the vector in rectangular coordinates, that is an x and y component, and we converted it into polar coordinates where you get a magnitude and an angle. Magnitude and an angle. Any questions? Okay. Das ist alles.